Welcome back to part 3 of our series on evaluating the trig functions of any angle. So now we're looking at worksheet 16. And you can see the difference this time. We're going to evaluate the trig functions. I'm going to give you the value of one trig function, and I'm going to tell you whether the second trig function, whichever other one of the 5 remaining, is positive or negative. This will help us narrow down which quadrant the terminal side of the angle resides in. Okay, because we need to know where to draw our triangle. It needs to be in the appropriate quadrant. That way the signs are correct as far as sine, cosine, and tangent. Which one's positive, which one's negative. Okay, so remember, in standard position, the angle starts at the positive side of the x-axis. And then we'll find out where the terminal side goes. So I'm going to do the same thing I did for the previous worksheet. I'm going to help you work through 2 of these with you together. And then I'm going to help set up 2 more. And then I'll leave you to finish off the homework assignment on your own. So you can see problem E here, the one I'm going to do in class right now. The tangent of theta is negative square root 5 over 2. So there's tangent, negative square root 5 over 2. Cotangent is going to be the reciprocal of that. So let's see, that's negative 2 over the square root of 5. If I rationalize that, negative 2 square root 5 over 5. All right, so there's our reciprocal. Now I need to figure out where I am. So I'm going to draw a little x and y axis to help me determine what quadrant I'm in. And then I'll use some colors here to help me. Tangent is negative. So I ask myself, okay, which quadrants is tangent negative? That would be quadrants 2 and 4. Tangent is negative in quadrants 2 and 4. Okay, for sine, green. In which quadrants is sine negative? Sine is negative in quadrants 3 and 4. So you can see here's where they overlap, which means the terminal side of my angle lies in quadrant 4. So I'm going to go ahead and draw an x and y axis. And I'll put my triangle in quadrant 4. Now remember how you draw the triangles? They always go to the x-axis. Always. Don't ever draw to the y-axis. Always go straight up to the x-axis or down. Okay. Reference angles are always in relation to the horizontal axis. So here's our reference angle, theta prime. And tangent, using SOHCAHTOA, tangent is opposite over adjacent. So opposite is square root of 5, adjacent is 2. And since I went down, I'm going to put negative with the square root of 5. And now I need to find the missing side of that triangle using Pythagorean theorem. Okay, so a squared plus b squared is c squared. And these are both the legs of the triangle. So this is 2 squared plus the square root of 5 squared equals c squared. That is 4 plus 5 equals c squared. So c squared is 9, which if I take the square root of both sides, means c is 3. All right, now I have everything I need. The sine of theta is opposite over hypotenuse. Opposite over hypotenuse. So the sine is negative square root 5 over 3. The cosecant is negative 3 over the square root of 5. And if I rationalize that, negative 3 square root 5 over 5. There's the cosecant. And the cosine is adjacent over hypotenuse, so the cosine is positive 2/3, which means the secant is a reciprocal, which is 3/2. All right, so there is problem E. Use these 2 values, whether they're positive or negative, to determine the quadrant the terminal side is in. Then wherever they overlap, draw that triangle in the appropriate quadrant, find the missing side, and then evaluate your trig functions. Okay. Next page. going to set up letter H here. Letter H says the cotangent of theta is square root of 2. Okay. So cotangent is square root 2, which means tangent is going to be 1 over the square root of 2. And if I rationalize that, that is square root of 2 over 2. Okay, let's figure out where I am. This is cotangent. Now, cotangent and tangent has nothing to do with the sign. In other words, you don't change the signs between tangent and cotangent. So that means if cotangent is positive, so is tangent. So cotangent, tangent, they're both positive. So in which quadrants is tangent positive? Tangent is positive in quadrants 1 and 3. Cosine, greater than 0. In which quadrants is cosine positive? 1 and 4. So it looks like I'm in quadrant 1. That's where they overlap. So go ahead and draw my x and y axis. Angle with the terminal side in quadrant 1. There is theta. And now, okay, let's see. Using SOHCAHTOA, cotangent is square root of 2. Tangent is 1 over the square root of 2. So I'm going to use this one. 1 over the square root of 2. Opposite over adjacent. Opposite, adjacent. So there's 1 square root of 2. Now they're both in quadrant 1, so that means they're both positive. So all we need to do now is find that missing side. Okay, those are both legs of the triangle, so I need to find the hypotenuse. So that's going to be 1 squared plus the square root of 2 squared equals c squared. And that is 1 plus 2 c squared. C squared is 3, which means the hypotenuse is the square root of 3. Okay, sine is opposite of hypotenuse. Opposite of hypotenuse. So sine is 1 over the square root of 3. Let me go ahead and jump over and do cosecant right now. That means cosecant must be square root of 3. And when I rationalize this, I get square root of 3 over 3. Cosine is adjacent over hypotenuse. Ooh, that's a little different. Okay, this is square root 2 over square root of 3. So the secant is going to be square root of 3 over square root of 2. When I rationalize this, I get square root 6 over 2. When I rationalize this one, I get square root 6 over 3. Let me show you that real quick. So I have the square root of 2 over 3 for cosine, and the square root of 3 over 2 for secant. To rationalize here, I'd multiply by square root of 3 over square root of 3, and that would give me the square root of 6 over 3. Okay, because square root of 2 times square root of 3 is square root of 6. Square root of 3 times square root of 3 is square root of 9, which is 3. Remember when they had the same radicand? That just comes out. Here I'm multiplying by square root of 2 over square root of 2. Square root of 3 times square root of 2 is square root of 6. Square root of 2 times square root of 2 is 2. So that explains those two solutions. Okay, I'll give you a moment here. Pause it if you need more time. Okay. Oops, I went a little too far with that one. I was only supposed to set it up. Oh, well, that's to your benefit then. Hope that helped. I did an extra problem. Okay, problem K, I'm going to solve this one, and problem L, I'll just set that one up for you. Hopefully I remember to do it and stop this time. All right, cosecant. The cosecant is 2 square root 3 over 3. Now, let's think about where did that come from? Where did 2 square root 3 over 3 come from? It must have come from that. 2 over the square root of 3. Because when that's the case, this radical, when you rationalize it, the radical comes to the numerator. So you get 2 square root 3, and then whatever was inside just comes out. So this cosecant was originally 2 over the square root of 3, which means the sign is square root of 3 over 2. Okay. So sine is positive. That is quadrants 1 and 2. Cosine is positive. That is quadrants 1 and 4. So once again, in this case, I am in quadrant 1. Oops, quadrant 1. So I draw my triangle in quadrant 1. And I would go here with sine. But we can stop for a moment and just think about this. Okay, the sine of theta is square root of 3 over 2. That's something I know from the unit circle. The y value is square root of 3 over 2. Now, where on the unit circle is the y value square root of 3 over 2? At these two locations, at pi over 3 and at 2 pi over 3. That's where the y value is positive square root of 3 over 2. Since I'm dealing with quadrant 1, then I must be talking about pi over 3. So all I'm really asking here is, what is the cosine of pi over 3? Oh, that's 1/2, which means the secant is 2. And if the angle is over 3, tangent is always plus or minus square root of 3. So in quadrant 1, it's positive, so tangent is square root of 3, which means cotangent must be the reciprocal of that, 1 over the square root of 3. So you rationalize that, and you get square root of 3 over 3. Let's see if this is true. So sine is opposite of hypotenuse. So this is square root of 3, and that is 2. Okay, now you already made me thinking this doesn't sound right, because on the unit circle, the hypotenuse is 1, and then all the other sides are square root of 3 over 2 or 1/2 for the 30, 60, 90. But this hypotenuse is 2. That's okay. What we're thinking about here is not the exact unit circle. We're thinking about the ratio of sides. So a squared plus b squared is c squared. So what I have is a squared plus the square root of 3 squared is equal to 2 squared. A squared plus 3 is 4. Subtracting 3 to both sides, a squared is 1. Taking the square root of both sides, a is 1. 1. Okay. So this is theta. Then cosine is adjacent over hypotenuse. Adjacent over hypotenuse, that's 1 over 2, 1/2. Tangent is opposite over adjacent, square root of 3 over 1. See, it doesn't look like it's on the unit circle, but imagine dividing all these sides by 2. 1 square root of 3 over 2, 1/2. See, it's just a ratio of sides. Okay. So what I'm trying to tell you here is if you recognize, if I give you the value of a trig function and you recognize that from the unit circle, once you know the quadrant we're in, you can determine the angle you're dealing with from the very beginning. And then you don't need to build a triangle and find the missing sides. If you can figure out where the angle is, you can deal with it right away. For example, look at letter F. Cosine of theta is square root of 3 over 2. I recognize that from the unit circle. Where is the cosine of theta square root of 3 over 2? That's the x value. Which two angles have an x value of square root of 3 over 2? That is pi over 6 and 11 pi over 6. Okay, well, based on this information, it'll tell you which quadrant you're in, and once you know the quadrant you're in, you can determine which of these two angles to use, and then evaluate the 6 trig functions. Okay. All right, let's set up letter L. Letter L. First of all, let's take a look at that. Secant of theta is negative 3 over the square root of 5. Well, let's see what that really was. What was that really? This is negative 3 over the square root of 5, right? Because if I rationalize that, that's what I would get. So this is the secant of theta. That's where I get negative 3 square root of 5 over 5, which means the cosine must be negative square root 5 over 3. The reciprocal of this. I just saw where that came from, and it looked to me like it was rationalized. So I imagined that radical back there. If you can't do that, it's not a big deal. Just take negative 3 square root 5 over 5. And then when you rationalize that, you get negative 5 over negative 3 square root 5. So what happens is you multiply this by square root 5 over square root 5. We're going to get a space there. And when you do, you get negative square root 5, you get negative 5 square root 5 over negative 3 times 5. And those 5's reduce. So you're left with negative 5 over square root 3. There shouldn't be two negatives, just the one. Okay, but that's a little bit, that is more complicated to me. Once you realize that it has been simplified, has been rationalized, send that back and then just take the reciprocal. Much easier that way. Okay. Let's see. Secant or cosine is negative. Cosine is negative in quadrants 2 and 3. Tangent. Tangent is less than 0. Tangent is negative in quadrants 2 and 4. So I'm talking about quadrant 2. All right. It's my x and y axis. Oh, I should have. That's a little too far this way, because I'm actually dealing with quadrant 2. So I'm going to slide that over. There's my y-axis. Now in quadrant 2, there's the reference angle, theta prime. And cosine is adjacent over hypotenuse, and that's going to be left, so negative. Now I need to find that missing side. A squared plus b squared is c squared. All right, that's a squared plus the square root of 5 squared equals 3 squared. Which is a squared plus 5 is 9. Subtracting 5 to both sides, a squared is 4. And if I take the square root of both sides, a is 2. 2. Okay. And it is in quadrant 2. So this is a positive y value because it goes upwards. All right. Now you're ready to evaluate the remaining 4 trig functions from letter L. Good luck on the homework assignment. Everybody, make sure you're taking care of yourselves and staying well. I'll see you next time. Bye.